Okay, in this video, we're going to create ourselves a reference sheet that we can use when we're doing these proofs, that we can go back and we can look at previous definitions and properties and everything we've covered. Now, first off, all your properties of equalities are listed here, and we can go back and watch previous videos to remind us if we don't remember what any of those properties are. It says the properties above may only be used with equal signs, though, because each of these are properties of equality. So if you have a congruent symbol, you can't use these. The following properties, however, properties of congruence can be applied to all statements with congruent symbols. So your properties of congruence are the following. First off, the reflexive property of congruence. The same way we have a reflexive property of equality, the reflexive property of congruence pretty much says the exact same thing, except for we're talking about congruence instead of equality. So for any statement or for any segment AB, that line segment will always be congruent to itself. Now notice I put the symbol above it because we're talking about the actual line segment, because our reflexive property of equality says AB is equal to AB without the symbol, because now we're talking about a length. The distance from A to B is equal to the distance from A to B. Next up, your symmetric property of congruence. Again, it's the exact same thing as the symmetric property of equality, except for we're talking about congruent symbols. If you have a line segment AB that is congruent to a line segment CD, that means that line segment CD is also congruent to line segment AB. You can flip-flop the order. That's what the symmetric property says. And then finally, your transitive property of congruence says that if AB is congruent to CD and CD is congruent to EF, that means that AB would also have to be congruent to EF. So that is your transitive property of congruence, which again is just like the transitive property of equality, but now we're actually talking about the shapes and congruence instead of the lengths and equality. Now let's go back and remind you of some previous definitions that you need to put on your reference sheet here. The definition of congruence says that segments are congruent if and only if they have the same measures. That's the definition. So that means if AB is congruent to CD, by this definition of congruence, that means that their lengths must be the same. So if they're congruent, their lengths are the same. If their lengths are the same, it works forwards and backwards. If their lengths are the same, then that means the two shapes are congruent. So that is your definition of congruence. Next up, the definition of a midpoint. Again, we've already done this. This is previous lessons, but we're just creating this reference sheet. The midpoint of a segment divides the segment into two equal or congruent parts. So if M is the midpoint of AB, and we're going to use this one a lot, and you can draw this. If you got line segment AB, and if M is the midpoint, that means that AM has to be the exact same length as MB. Or since we throw in congruent here, we could also say that AM, by the same definition, AM is congruent to MB. You can word that either way, and that's going to be very important to us down the road. And finally, the segment addition postulate, again, a very old theorem from several lessons back. If A, B, and C are collinear, notice they're on the same line here, and B is between A and C, then that means that the length from AB plus the length from B to C has to equal the length from A to C. AB plus BC has to be the entire length.